Hi and welcome to the third video in the series about testing with F# with Expecto, the testing library. In this video we'll go through how to set up a development workflow for you and how to do then continuous coding, compilation and testing in this workflow. We'll start by looking at how to create a solution being something that contains multiple projects, and we'll have one project for testing and one project for your code itself. We'll use the F# interactive to load and execute your code, and then .NET Test and .NET Watch for continuously compiling and running your tests. We're going to use the IDE called Rider, which I prepared here. So I have this template, which automatically is shown because we installed it in the previous video. We're going to use this template, which is from a shell, to create both a solution and a project. The solution being something that we can open in Rider. We'll also create a Git repository so we can track the code changes we make. And we want interactive testing, the folder name, to be under demo, which we're in here. And then the testing library, the testing program itself, to be in the tests folder. And then having the solution at the root. So we'll create this now. Okay, so here we go. Let's see if we can compile this. Right. So in this case, we named our module the same thing as we did the main. So let's just call it test, and or rather active testing test, and we'll do interactive testing main. So now we should be able to compile it. Yeah, here we go. And we should be able to run it. Again, this is a sample. So we can see these example tests. Let's just delete those for now and open Expecto and Expecto flip so we can write our own code. Right, so now we have one project called tests. We also want to add one more project, which is called library. So let's just add a class library, call that lib as .NET Core App v3.1 F#. And let's keep this. Let's use say. Let's just call that lib and then the module say. Another way of writing it would be say like this. Nice way as well. And now we can test it. So in our sample, what we want to do is do a new test. And you can see there is also this test builder you could use if you want to. So you can say testing say, and then a squiggly, a curly bracket as it were, and do lib say hello and Henrik, and then do expect equals message. So this won't compile. Let's try to compile it with Command B and see what happens. It says library isn't defined. What can we do? Well, what we can do is add a reference to it, like this. And now let's see if we can compile. So this returns a unit, but we want to assert on a string. Then what we have to do is make sure that hello here returns a string instead. So let's do an sprintf here. And let's rerun the test. So far, we've done everything like we usually do it, just to show how to link two projects together. How to link lib into test, so that the test project, which is a program, can do the testing of lib. So with that done and said, now we want to go into the terminal. And we want to go to interactive testing to see what's in here. We got the solution file. The solution file is just one of these, a text file detailing these test projects with this archaic format. You don't necessarily have to use it, but it's useful if you have an IDE to use it. Then we also have the library folder. In here we got the fsproj. We got two runtime artifacts or compilation artifacts called bin and object. And in the other one, in test, we have a similar setup. If we look at the fsproj here, we can see that we now have a link to the library project. And we also have a link to Expecto and the test SDK. This test SDK is important in order to be able to do .NET Test. You can see I'm in the test folder and I'm running .NET Test. And it's pausing. All right, here we go. So what if we wanted to continuously test this? What we can do is add watch in front of test. And it'll add a watch to any test file that we might change. So let's bring these up side by side so that we have the testing and the running of the test. And let's create a new test. Let's do it with the other syntax this time. And do lib. Actually, what we could do is we can open that. So let's just do say. I use tab here to complete and it opened lib for me. That means I can now do this. Let's do a failing test first. To the left-hand side, you now see the watcher ticking because it noticed that this file has changed. It'll now give you a diff of the different strings between the expected value and the actual value. So let's do another one. Let's change this now to be a actual working test. All right, there we go. That's how you do continuous testing. Let's see if that also works for this library. Seems like it does. Very nice. And let's move back. Now let's say we had a more advanced function. Something perhaps that multiplied something else with pi. Let's see how we could try that out as we type it. Let's always return 2 initially. Nothing happens with the test, and that's quite normal because we haven't actually changed or added any tests, nor have we called this new advanced function. This underscore is just a way of saying it can take any parameter, any argument, and it's still a function. So inside of our library, that's where I normally put my FSX files, my interactive files. I put one of these, a script file called interactive. Now what I can do is I can do a load, which is the command to load a library file into your current execution environment, and then use option prime, the single string tick, to load it into the interactive. And I have the interactive here, but I could just as well go into lib and do .NET FSI interactive and have exactly the same thing happen. Now, this didn't give any output because I'm not actually doing anything. But let's say I did a printf hello. If I run it like this, it should print hi. But if I only do FSI, I should be able to run the same commands on the command line as I run through the IDE. And then I can do This is in the lib folder, so I have to open lib first, and then I can do advanced. Sorry, let's have a look again. It's in lib.say. I can do say advanced, and then I get 2 back. Similarly here, if I wanted to test something, I could quite easily do that here. Let's open lib. And then send that to the interactive. And I get it here. As I then add more code or change it, I have to reload it. So I go up to the load, do option prime again, and then run it again to get the new result. So that's how to do interactive testing and coding on a Mac OS with Rider for F# and Expecto. So what's up next, and what's funding this? This series of videos is funded by github.com/hafta/sponsors. And what I'm doing is that I'm preparing a video for each consecutive goal I reach. The next video will be at 7 sponsors, and we'll go through how to test asynchronous tasks. So if you find this useful, go in and sponsor me, and see you in the next video. So here I am, sitting at Södermalm in Stockholm, finishing the video, and I hope you enjoyed it as much as I did creating it. See you next video.